right, guys, if you remember, so far we've learned how to find the area of a two-dimensional figure, how to find the surface area of a three-dimensional figure, and now we don't just want to learn how much space their faces take up. We want to find out how much space they all take up, just how much three-dimensional space a shape takes up. So what we're going to do to find the volume of figures is we are going to, specifically for rectangular prisms, the equation is really easy. It's length times width times height. So if you remember, length times width is the way we find just the area of a two-dimensional flat shape, like a square. Okay, so that's like finding how much space just one of these sides takes up if we multiply the length times the width, right? But we also want to know the height this time. So we want to add on a third dimension to that shape. So we're not only going to multiply the length times the width, we're going to say how high is that length times width stacked up? So our area is super easy. Our volume is super easy. The volume equals the length, which is 17, times the width, which is 9, times the height, which is 24. And we literally just have to multiply that all together, and that equals 3,672. And now, this time we were working with centimeters, but now we're working with three-dimensional space. So instead of square units, we're using cubic units. So it's centimeters cubed because it's three-dimensional. All right, guys, let's try a different type of prism. We are going to practice with a trapezoidal prism because I think we're used to seeing triangular prisms. So we're going to just try to take a look at a different kind of prism. So the volume that we were given for any type of prism is big B times H, okay? Where big B, just like we use in some of our surface area formulas, is the area of the base. And by base, it doesn't just mean one line, okay? It means the base of this entire prism. So if you remember, prisms are shapes or three-dimensional shapes where it has two sides that are exactly parallel or exactly opposite of each other. And those two sides have to be the same shape, so, and the same size as well. So I'm just going to look at my prism here. I see maybe this top and bottom, that's exactly opposite of each other, but I see this bottom way bigger than that top. These two sides are opposite of each other, but they're not exactly parallel, going in the same direction. But I do see this front side, it looks kind of like a trapezoid, and this back side that also looks like a trapezoid, that they should be the exact size and shape. So I'm just going to highlight what I'm talking about. That's my back side. And then this trapezoid, I can outline it here, is my front side. So those are my bases of this prism. This means it's a trapezoidal prism. Okay, so if I want to find the area of the base or the area of that trapezoid, I need to use the area formula for a trapezoid. So big B equals, if you remember, our area formula for a trapezoid is 1/2 times the height of a trapezoid. Now we're saying the height of just that face, okay? And we're not talking about the slant height, we're just talking about the height. If you remember, height is the distance from the tallest point of that shape going down perpendicular from one of the bases, okay? So that shows me, since this line, I have this little square here, saying that this line is perpendicular, so that means this is the height of my trapezoid. And I have a little arrow here that points to it. It says it's 17.9 meters, okay? Then I have to multiply that by base 1. Oh, let me give you the formula first instead of plugging things in. We'll do it one step at a time. Height times base 1 plus base 2. That's my formula for a trapezoid, just a flat two-dimensional trapezoid. That's how I find the area. Okay, now I'm going to plug things in. Base equals 1/2 times the height, which I pointed out, it's 17.9. times base 1 plus base 2, and this is little b's, right? So they're not finding a big B. I know there are a lot of variables in these formulas, but B1 plus B2, notice that the trapezoid has different sized top and bottoms that are parallel to one another. So that is 36. One of them is 36 meters long. And plus the top one is 14 meters long. If these two are congruent to one another, then if that's 14 meters, that's also 14 meters. So that is how I find the area of my trapezoid base. So I am just going to calculate it out and punch it in my calculator. And if you do it with me, you should get 447.5. And this is meters squared because I am finding two-dimensional area, just that flat trapezoid. But I'm going to multiply that two-dimensional area, that flat trapezoid, times the height of my figure. So this is the height of the entire prism, okay? So it's not just how tall one of the faces is, it's how tall the entire prism is. So I find the height of my prism by identifying my two bases, right? Which we've already figured out. It's this front face and that back face, okay? So the height of my entire prism is the distance between those two bases. So it's from this base to that base. So it's this distance, which is going to be the same for all of these. And it tells me the distance is 25. Whoops, I erased everything. Okay, so to find the volume of my trapezoidal prism, I am going to multiply 447.5 meters squared, okay, times the height of the prism, which is the distance between the two bases, which it tells me that it's 25 meters. Okay, meters squared times meters is meters cubed, right? So remember, we're dealing with three-dimensional space, so we should be working with cubic units. So if I multiply these two, it'll give me 11,187.5 meters and then cubed. And that is it. So remember, only use the area formula of the base of the type of prism it is. So if it's a triangular prism, if the base is a triangle, then you need to find the area of that triangular base. If it's a rectangle, you find the area of that rectangular base. But if it's a trapezoid, you use the area formula for a trapezoid. All right, guys, so last example is a cylinder. So you guys know a cylinder is a type of prism. The only difference is that the bases of this prism are circles instead of a trapezoid or a rectangle or a triangle. So I already kind of drew and highlighted our two bases because they're circles. It's pretty obvious. If you remember, the volume formula for prisms is just big B, which is the area of the face times the height of the prism, or the distance in between the two bases. So what we're going to do is we're just going to find, just like that formula, we're going to find the area of the base, which if the base is a circle, then the area formula is pi r squared, and we're going to multiply it by the height of the prism, which is the distance in between the two bases. I'm going to just plug it into my formula. Volume equals pi times the radius of the circle, which is the distance from the center to the edge of the circle. So it's 18 squared. Remember, sometimes they'll give us the diameter, the full distance, but we only need half of that. We only need the radius. And we multiply it by the height of the prism, which is 15, because it is the distance between those two bases. Then I'm just going to multiply it out in my calculator. I get 4,860 pi. And once I multiply by pi, I get 15,268.14. and we're measuring in inches, but this is three-dimensional space. We're measuring how much space this whole cylinder takes up, and it's a three-dimensional cylinder. Well, all cylinders are three-dimensional cylinder, but it's a three-dimensional shape or figure. So that is being measured in cubic inches, or inches cubed.